Welcome to the Matrix. Because when you look at a Cambridge computer science exam paper, you might just see a bunch of confusing questions and complex scenarios, right? But top students? They don't see the paper. They only see the patterns. They see the code behind every single question. And today, we are going to decode that exam reality for the Cambridge AS and A-Level 9618 syllabus. We're zooming in on one of the most critical structural concepts you'll face: mastering data definition language, specifically the SQL DDL alter table command. I'm going to hand you the exact blueprint to maximize your marks, based strictly on leaked, confidential examiner reports. But first, let me paint a picture for you. Imagine two students taking this exact exam. We'll call them Alex and Sam. Now, Alex overloads his answers with raw computer science facts. He's basically a walking textbook. He drops a massive data dump of every SQL command he knows, but there is zero actual analysis of the question. Then you have Sam. Sam rushes. The clock starts, and Sam just starts writing, completely missing the specific command word requirements hidden in the prompt. Both of them walk out thinking they nailed it. Both of them are going to be shocked on results day when they see their papers covered in red pen marks. We're going to fix that today.
Look at this quote. What's really interesting about this statement straight from a senior examiner is that it immediately establishes the absolute high-stakes reality of this exam. Read that carefully. This topic appears in every examination series. You literally cannot hide from the alter table concept on exam day. It's not a suggestion. It's a fundamental pillar of database architecture within the 9618 syllabus. It tests not just your rote memory of SQL syntax, which is exactly where Alex goes wrong, but your genuine ability to adapt and manipulate data structures dynamically. If you just memorize the syntax, you get the red pen. The examiner wants to see if you can manipulate a live database without breaking the whole system.
So to get you those top marks and bypass the mistakes Alex and Sam make, we are going to structure this explainer into 5 crucial areas. First, the challenge. Second, core principles, where we reveal the strategy. Third, the procedural framework, where we transform bad answers into perfect ones. Fourth, the interactive workshop using examiner warnings. And finally, the evaluative framework. Let's get into it.
Okay, let's start by addressing the biggest hurdle students face right out of the gate in Section 1, the challenge.
Our source material reveals something fascinating. Students actually don't struggle with the basic syntax of typing out alter table. I mean, the code itself is pretty straightforward, right? The primary challenge, and this is where most marks are lost, is applying these theoretical concepts to the entirely unfamiliar, weird, and wonderful contexts Cambridge throws at you. One year, the exam paper presents a legacy hospital database. The next year, it's a cutting-edge drone delivery tracking system or a global logistics network. The hurdle is bridging the gap between raw theory and these highly specific scenarios. This is exactly where Alex fails. He writes out the textbook definition of altering a table, but he forgets to mention the hospital or the drones. He gives generic code, and the examiner gives him 0 marks for application. And Sam doesn't even read the drone schema properly before writing the code.
So how do we build a foundation to overcome that context challenge? Let's dive into Section 2, Core Principles, and reveal the ultimate strategy.
To overcome the challenge of unfamiliar contexts, you need a firm grasp of the theoretical architecture. This means precise definitions and causal relationships. When you use alter table to change a table definition, you aren't just typing a command. You are fundamentally altering the entire data dictionary. You're impacting data integrity, potentially affecting entity relationship diagrams, and modifying core data types. The syllabus highlights that top-performing students always exhibit this connected understanding. They decode the command words. If the command word is evaluate, they don't just describe. To do this perfectly, top students use the PEEL framework: point, evidence, explanation, link. You make your point about the SQL command, you provide evidence from the drone database schema, you explain why the alteration works, and you link it back to the system's performance.
This brilliantly illustrates the Cambridge assessment benchmark. Examiners are actively looking for logical, structured reasoning, and deep analytical thought. That's your analytical depth. They actively penalize a superficial breadth of scattered facts, which is exactly Alex's data dump strategy. It's not about listing everything you know about databases. It's about making a specific, targeted point using that PEEL framework. I want you to look at the screen right now. We're putting 30 seconds on the clock. Mentally, try to spot the difference between an answer that just lists app-SQL commands and an answer that uses PEEL to explain why the command is used. Take a few seconds. You see the difference? Depth always wins. And hey, before we continue breaking down exactly how to achieve that depth, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Keep in mind that every single question on that paper is targeting these specific cognitive domains. Your answer needs to hit all 3 marks. Knowledge and understanding, that's your assessment objective 1. It's your basic recall of SQL DDL commands. Application, or AO2, means taking that knowledge and using it to solve the specific hospital or drone database problem sitting right in front of you. And analysis, AO3, is where you evaluate the impact. If you use alter table to drop a column, what happens to the queries relying on it? That's the level of thinking that gets you an A star.
Let's move into Act 3, the transformation. Here is Section 3, the procedural framework. We are going to watch some red pen marks turn into green check marks.
Let's look at how this builds a repeatable framework, our computer science success blueprint. If you follow these 5 steps exactly, you will secure vital method marks, even if your final answer has a minor flaw. Let's rewrite Alex's terrible answer right now. Step 1, deconstruct the question. We identify the command word. Step 2, extract relevant data. Instead of Alex using a generic table name, we extract TBEL drone flights. Step 3, select the analytical framework. We realize we need to add a new column for battery life. Step 4, execute with clear notation. We write the exact SQL. Step 5, present with correct terminology, stating we are modifying the data dictionary using data definition language. Boom! Alex's answer just went from a D grade to an A grade. We just secured all those previously lost marks.
Now let's fix Sam's answer during the procedural execution. Remember, Sam rushes and misses the details. Sam's algorithmic thinking needs to shine through step-by-step decomposition. The exam asks to alter a table to accommodate a new currency format. Sam just writes INT. But if Sam stopped and interpreted the data given in the exam correctly, they'd see the currency has decimal points. You have to deduce the correct data type, modifying an INT to a decimal or float based on the evidence provided in the text. It's all about making those evidence-based conclusions. Sam rewrites it, changes the data type, and suddenly those red marks turn green.
We are heading into the most crucial part of our explainer. But wait, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump into Section 4, Examiner Warnings, and kick off our interactive workshop.
These warnings are pulled straight from the principal examiner reports, and we are going to turn them into a workshop right now. Challenge 1, data scan. Imagine a complex database schema on your screen. You have 60 seconds. You need to extract the core trend. The examiner warns about forgetting boundary conditions, warning number 2 on this list. If the question asks you to alter a string length from 50 to 20 characters, the edge case is what happens to existing records that are 30 characters long. They get truncated and data is lost. Did you spot that in the data scan? Challenge 2, find the flaw. Look at warning number 1, vague answers. If a sample paragraph says, use alter table to change the column, that is the flaw. It's too vague. You must specify which column and what data type.
And here is Challenge 3, speed writing. We are putting 30 seconds on the clock. You need to write one perfect Peel paragraph based on this examiner alert. The crucial point here is that a perfectly memorized generic definition of alter table will lose you marks if you don't connect it to the specific database scenario. Go! Point. State the alter table command. Evidence. Mention the specific table name from the prompt. Explanation. Explain why the new data type is needed. Link. Relate it back to the system's efficiency. Time's up. If your paragraph looks like that, you just bypass the classic mistake that ruins thousands of exams every year.
We're in the end game now. Act 5, the final system. Let's look at Section 5, the evaluative framework.
This table provides your ultimate deconstruct, solve, evaluate loop, and it forms the basis of our complete Cambridge answering system. There are 3 rules that guarantee top marks. Rule 1, command word decoding, deconstruct the prompt perfectly. Rule 2, PEL framework application, solve systematically by providing evidence and explanation. Rule 3, time management matrix, evaluate your algorithm quickly by checking for reasonableness. When you use alter table on massive data sets, it eats up computational space and time. A top candidate evaluates that impact. They check if changing a primary key is reasonable or if it will completely shatter foreign key constraints across 5 other tables. You must master this loop.
To prove to the examiner that you truly understand the matrix of database architecture, your final step should always demonstrate this high-level evaluative thinking.
This is what separates an A from an A star. Consider multiple solutions before you write your SQL. Analyze the trade-offs of your chosen statement. Will it be fast, but use more storage? Acknowledge limitations like potential downtime while the table alters. And most importantly, justify every single decision with hard evidence from the prompt. If you do this, you become unstoppable.
So, here is the final question you need to ask yourself. How will you adapt your exam strategy today to ensure every single alter table point you make links directly back to the given scenario? Students who implement these exact computer science strategies see an average improvement of 2 full grade boundaries, but that only happens if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.